In the 1970s, these three scientists incorporated quantum mechanics into computer program based on molecular mechanical models and paved the way to multi-scale modeling for computer simulation. They took laboratory into cyberspace. Looking at molecular motors or cell signaling, most people must have thought that it is hopeless to understand a complex system at the level of mechanical models. Dr. Warshel is one of the very few who works on it persistently. He entered Technion of Israel in the era of scientific discoveries on proteins, when biochemistry discovers the clock, crystallography showed all the parts, and single-molecule spectroscopy reveals how fast it rotates. He took a class on quantum mechanics and started to get himself interested in enzyme catalysis. Why the reaction becomes so fast, some in the magnitude of 20? In his graduate school, he started to develop computer program based on molecular mechanics, treating atoms and bonds as balls and springs. Organic molecules are simulated using powerful computer of the time, Golem of Weizmann Institute. With newly met Leavitt, he continued to refine the model of Lifson and added quantum mechanics of valence bonds into the algorithm. He then went to Harvard University as postdoctor to develop a method incorporating quantum calculation of molecular orbits with Karplus, which explained the behavior of electrons on retinal. 2 years later, he returned to Weizmann to continue his pursuit on enzymes. He input Leavitt's calculation from Cambridge on lysosomes into his program and discovered that the bonds did not break. They soon realized the energy hurdle of reactions in water versus in protein molecules. They did not simulate enzyme catalysis successfully until they figured out the coarse-grained method, focusing only on the reaction region, using the more demanding quantum mechanics, and treating the surrounded using method. Do not try to invent chemistry in computer, as he puts it. For instance, this animation simulates phosphor hydrolysis. As he puts it, doing movie is the simple part. Much harder is to get meaningful numbers by doing free energy calculations. In 1974, they made major progress at MRC to simulate catalysis of lysosomes with quantum calculation, taking into account of electrostatics of enzymes and water environment, including charges and dipoles. Since then, QM-MM method replaced the previous QM plus MM approach and formed the basis of simulation softwares in use today. In 1976, he published the paper on retinal conformation after struck by light and subsequent animation, which demonstrates the first reaction of animal vision. Their programming incorporating quantum mechanics into Newtonian mechanics has driven the computational biochemistry in waves of progress.